Welcome to my video on stoichiometry. Before you watch this video, I want you to watch the videos on mole concept and balancing chemical equations. You will need to know both of these concepts, and combining the two concepts mentioned in the videos, let's move on and learn how to predict the products in a chemical reaction from a known mass of reactants or the reactants in a chemical reaction given some information about the products. So what I have here is a procedure. The first step is to read the question and identify the given information and the unknown. In other words, what are they looking for? Then you want to balance the chemical equation. Write a letter G above the formula of the given and a question mark above the formula of the compound you're seeking information on. I then want you to create something that looks like a rectangle, and it must originate from the given and head towards the question mark, but it has to have a rectangle with 4 known corners. The top corners are reserved for mass values. The bottom 2 corners are reserved for mole values. And you want to create arrows originating from the given, so you have an arrow going down here as I'm showing, then across and heading towards the question mark. If the arrow is going down, you want to multiply by 1 over molar mass. Down for decreasing and for dividing. It's kind of easy to remember. Going across is multiply the answer by the coefficient of the question mark divided by the coefficient of the given. And going up is multiplying by the molar mass of the compound that the arrow is pointing towards. From the question, you will identify which is the given and follow the arrows to set up the analysis with units. You could be given the mass or the mole, and you could be asked for the mass or the mole. Once you've identified what is given and created your arrows, you need to identify your stop box. So here's a generic example. Let's say this was the balanced equation, and some information about A was given. In fact, the mass of A was given, and they wanted to find some information about C. Let's just say that they asked for the number of moles of C. You will first write the given, G for given, question mark above C, and you will originate from the given and create your rectangle. Bear in mind, the top boxes are for masses and the bottom boxes are for moles. You are asked for moles of C, so put a little stop sign here so you know this is where you're going to stop. This is where you're going to start because the mass is given. Write down the mass, and then you follow the arrows, so you're going down towards moles, and your instruction tells you to multiply by 1 over molar mass of A. So you're going to multiply by 1 over the molar mass of A, and then you're going to continue along this line here and stop right here. Going along this line here, you will multiply by the coefficient of the question mark over the coefficient of the given. And you stop right there, pick up your calculator, figure out the answer, and make sure that your final answer is in the lowest significant figures. Now let's say, for argument's sake, they wanted the mass of C. So the mass box is over here. Right here is the mass. Again, if A is given, you're going to originate the arrow from A, turn around, create your rectangle, turn back around, and head towards the question mark. Again, we're going to use the given mass of A. We're going to go down by multiplying 1 over molar mass of A, going across by multiplying by the coefficient of the question mark over the coefficient of the given. But we won't stop here. We have to continue. We need to stop at the mass because the question asked for the mass. So you're going to go one more step here and multiply by the molar mass of C over 1. Pick up your calculator, figure out the answer, Reduce the answer to the lowest significant figure, and that's your final answer. Let's go ahead and do a real example. The question is, one disadvantage of burning propane is that carbon dioxide is one of the products released. The released carbon dioxide increases the growing concentration of carbon dioxide in the atmosphere. The question is, how many moles of carbon dioxide are produced when 10 moles of propane are burned in excess oxygen in a grill? So you are told that the starting material is propane and oxygen. Types of reaction will tell you that anytime something is combusted, the products are automatically carbon dioxide and water. So even if they didn't tell me that one of the products is water, I would know that. Write the balanced chemical equation, and I covered this in another video. So they're looking for how many moles of carbon dioxide are produced, which means the formula for carbon dioxide gets a question mark directly above the formula when 10.0 moles of propane are burned. So something is given, put a G above propane because you know something about propane. Then create your rectangle. Originating from the given, turn around and head towards the question mark. Remembering that the top is for the mass and bottom is for the moles. Go back to the question and find out what's given. 10 moles of propane is given. And I put a little 10 there to remind myself that this is given. I'm not ready to solve the problem yet. I need to know what they're asking for. I already know that they're asking for the moles of carbon dioxide. Well, the top is the mass of carbon dioxide. This is the moles of carbon dioxide. I'm going to put a little stop here to remind myself not to get carried away with my analysis here. Always start with the given. So you're given 10 moles of propane. And your direction goes from 10 moles of propane and you stop right here. All you have to do is multiply by the coefficient of the question mark divided by the coefficient of the given, which is 3 moles of carbon dioxide over 1 mole of propane. And then you pick up your calculator and figure out the answer, and you will find that your answer would be 30.0 moles of carbon dioxide. You see 1 mole of propane and the units cancel out. I noticed that decimal is present, so the number of significant figures is figured out by counting from the left, 1, 2, 3. So I need 3 significant figures right here. Let's try another problem here. Ammonium nitrate is an important fertilizer, produces dinitrogen oxide gas and water when it decomposes. Determine the mass of the water produced from the decomposition of 25 grams of solid ammonium nitrate. So what's given? Something is given here. And what are they asking for? Determine the mass of water produced. So water gets a question mark right over here. Create your rectangle first, originating from the given, heading towards the question mark with your arrows pointing in the right direction. Understand that the top box is for mass, or top position is for mass, and the bottom position is for moles. Go back to the question. Find out what's given. We are given the mass of ammonium nitrate. So the 25.0 is over here. And we need to start out with 25.0 grams of ammonium nitrate. And the next thing we're asked to do is to go down. Going down means 1 over the molar mass of ammonium nitrate. So we're going to have to multiply by 1 over the molar mass of ammonium nitrate, which is 1 mole of ammonium nitrate over 80.04 grams of ammonium nitrate. I recommend you view the mole video again just to see how the units have turned out, Essentially, it is 80.04 grams per mole. But remember, if you're dividing by grams per mole, this mole goes in the numerator position, which is how I got this unit here. That takes me down to this position here, and it'll give me the moles. But I need to find out the mass. So this is my stop. I need to find the mass of the water. I've got to figure out the number of moles of water, and then from the moles of water, I have to figure out the mass of water. So to get to the moles of water, it is multiplied by coefficient of the question mark over the coefficient of the given. So 2 moles of water divided by 1 mole of ammonium nitrate. Not done yet, because I need to multiply by the molar mass over 1. Going up, the numbers go up, so you multiply by the molar mass. And the molar mass of water is 18.02 grams. So let's just go ahead and say 18.02 grams of water per 1 mole of water. And here the units do not get reversed because we're not dividing, we're multiplying. Grams of ammonium nitrate cancelled out, moles of ammonium nitrate cancelled out, moles of water cancelled out. Then your final unit is grams of water, which is what you want. Pick up your calculator, figure out the answer, reduce it into the lowest significant figure, and that's your final answer. Okay, I've gotten this problem started. I'd like you to pause the video and try this on your own. The question is, in the formation of acid rain, sulfur dioxide reacts with oxygen and water to form sulfuric acid. So sulfur dioxide plus oxygen plus water gives you sulfuric acid, and this is the balanced chemical equation. So pause the video and try this on your own. Did you try this on your own? So what's given here? Write the balanced chemical equation, which is what I'd already done. 2.50 grams of sulfur dioxide is given. So I'm going to put given here. And how many grams of sulfuric acid? So this is the question mark right here. And let me create my guiding rectangular arrows. Top was mass. And they gave me 2.50 grams. And they're asking for grams of sulfuric acid. So this is what they're asking for. So maybe I should put a stop here to remind myself that that's what's being asked. Okay, starting out with 2.50 grams of sulfur dioxide, I need to go down, so it's multiplied by 1 over molar mass of sulfur dioxide. So multiply by 1 mole of sulfur dioxide per the molar mass of sulfur dioxide, which is 64.07 grams. Then going across is the coefficient of the question mark over the coefficient of the given. So 2 moles of sulfuric acid divided by 2 moles of sulfur dioxide. That brings me to this point here, but I need to figure out the mass of sulfuric acid. Going up means multiply by molar mass over 1, so I will multiply by the molar mass of sulfuric acid, which is 98.09 grams of sulfuric acid per 1 mole of sulfuric acid. Cancel your units: grams of sulfur dioxide, moles of sulfur dioxide, and moles of sulfuric acid. Cancel. The uncancelled unit is grams of sulfuric acid, which is what you wanted. Pick up your calculator, figure out the answer, reduce it to the lowest significant figure. Answer is 3.83 grams of sulfuric acid. Okay, here's a relatively easy one. Again, I'd like you to pause the video, try it on your own, and then run the video. Okay, I'm going to put up the answer. The balanced chemical equation We're asked to calculate the mole of CS2. So let's put a question mark here. When 1.5 moles of S8, so the given is here. And let's create a rectangle. We're given moles, so it's 1.5 goes here. And we need moles of CS2. So we start out with 1.5 moles of S8 multiply by 2 moles of CS2 over 1 mole of sulfur, and you can see they cancel out, and your final answer will be 3 moles. Let's just go ahead and create another rectangle, and it's here. Again, you start out with 1.50 moles of S8, and this is 1.50 right here, and you stop right there. And here the question mark now is on H2S, so you will multiply by the ratio of the coefficient of where you're going over where you came from, question mark over given. So this time you're going to multiply by 4 moles of H2S over 1 mole of S8. And your final answer will be 6.00 moles of H2S. Check your significant figures. Here we have 3, so we need to add decimals here to match our significant figure. So I want to say 3.00, and here you have 3. I already have 3, so we're good. Okay, I'd like you to do this problem all on your own. The question is, titanium is a transition metal used in many alloys because it is extremely strong and lightweight. Titanium tetrachloride is extracted from titanium oxide using chlorine and coke. If you begin with 1.25 moles of titanium oxide, so this is given here, what mass of chlorine gas is needed? So here's your question mark. Okay, pause the video and do it on your own, and I will tell you the answer in a minute. Okay, the final answer is 177 grams of chlorine needed. Well, this ends this video. Thank you very much for listening. See you again. Goodbye.